morning, everyone. I hope you guys have a great day, and I'm going to give you all of the notes on quadratic formula and the discriminant today, and then tomorrow we'll go through a few more examples in class, okay? So first thing you need to know about solving quadratics using quadratic formula is quadratic formula is derived from completing the square, and we're going to do that on Friday. And I'm going to prove it to you, okay? That's the last way of solving quadratics. So we've done parabolas, we've done factoring, now we're going to do quadratic formula, and then Friday we'll do completing the square. All right, so what you need to know is the quadratic formula. Quadratic formula is x equals opposite of b plus or minus square root of b squared minus 4ac divided by 2a. That's the quadratic formula. So when you have your quadratic in standard form, which is ax squared plus bx plus c equals 0, I hope you guys have that memorized by now, okay? You will use this to substitute values in for a, b, and c, and then you solve. So let's break that apart a little bit. First thing we need to do is the discriminant. That tells us how many roots we're going to have, how many solutions, okay? Which is what we've been working on, all right? The discriminant is this little part inside the square root, b squared minus 4ac. That is your discriminant. That's the first thing you're going to do anytime you're evaluating a quadratic using quadratic formula. Find your discriminant. That will tell you how many roots or solutions you're going to have, so it gives you a hint. So if your discriminant equals 0 after you've solved it, there's only one root, okay? If your discriminant is negative once you've done this, it's not going to have any roots because the square root of a negative number is not real. Remember, it's imaginary. So, can you take the square root of a negative number? No, you cannot. Well, you can, but it's imaginary. You're not going to learn that to Algebra 2 trick, okay? If, when you solve the discriminant is positive, you're going to have two roots. Now, there's two ways these roots can look. If it's a perfect square, let's say we do this and we get 144. Well, we know the perfect square, that's a perfect square because the square root of 144 is 12. So here you're going to notice this nice little handy dandy plus or minus. With square roots, what's the inverse of a square root? A square. When I do negative 4 squared, do I still get 16? Yes. When I do negative 3 squared, do I still get 9? Yes. That's why we add our little plus or negative. Positive or negative, okay guys? All right, and I'll explain more about that tomorrow if you'd like. So if we have a perfect square with the discriminant, it's going to be two rational roots, right? It's going to be two whole numbers, which makes it easy for us to solve this. If for some reason, let's say it ends up being the square root of 23, that's an irrational number, correct? So then we're going to leave it in simplified radical form. Okay, we'll get to that. So let's just work with discriminant right now. All right, so b squared minus 4ac. So let's do a couple examples on discriminant. So we're going to find the discriminant and we're going to tell how many roots. So b squared minus 4ac, okay? So first thing I suggest is that you write your values out for a, b, and c. Okay, so what's a? A is 1. All right, there's nothing in front of it. Hyphen b. B is 2. Positive 2, right guys? Yes. The dog's helping today. And c is 6. Okay? So then we're going to substitute those values in. So b squared, 2 squared is 4, minus 4 times 1 times 6. Okay? So what's negative 4 times 1? Negative 4. Negative 4 times 6? Negative 24. So 4 minus 24 equals negative 20. Okay, let's come back to our other board. If the discriminant is negative, how many roots, guys? None, right? So what you would say is no real roots. Okay, Now, what does that mean? I'm sure some of you are saying, okay, so why am I doing this? This solution is telling you how many times your parabola is going to cross the x-axis, okay? So remember, guys, when we were talking about our x-intercepts that very first day, and remember I've told you every day since that we're finding these solutions because it tells us how many times it's going to cross the x-intercept. So here, no real roots. That means the graph of our parabola is never going to cross the x-intercept. Which, if you think about it, that means it's going to go upward, right? Which means A is positive. Right, guys? See how it all comes together? I'm hoping it's starting to come together. Okay, so let's do the next one. 9x squared minus 6x plus 1. So b squared minus 4ac. So let's do our values for a equals 9, b equals negative 6, c equals 1. So b squared, negative 6 squared is 36 minus 4 times 9 times 1. What's negative 4 times 9? Negative 36. Negative 36 times 1 is negative 36. 36 minus 36 equals 0. So we are going to have how many roots? 1 real root. Okay? Means it's going to cross your x-axis at one point. Okay? All right. Then if we look at, let's do this last one too. I'm hoping this is making sense. All right, so we have 10x squared plus 11x minus 6 equals 0. All right, b squared minus 4ac, so let's do our values. A equals 10, b equals 11, c equals negative 6. Okay, so b squared, 11 squared is 121, minus 4 times 10 times negative 6. Negative 4 times 10 is negative 40. Negative 40 times negative 6 is 240. So we have 121 plus 240. What's 121 plus 240? 361. All right, so I'm going to test you guys. 361 is under my square root. So it's positive. We know that means it's 2 real roots. I want you guys to think about it. Is 361 a perfect square? It is. Anyone want to guess? It's 19. Okay, so remember how I've been drilling that you need to know your perfect squares? This is why. Then you're not sitting there going, I have no clue if that's a perfect square. Now you do. So it's 19. So we know we're going to have 2 rational roots when we solve this one. And we are going to solve these using the full quadratic formula here in just a minute, okay? All right, so we know that this would be 2 real roots. And actually it would be 2 real rational roots, right? Okay. So I'm hoping that's making a little bit more sense, okay? So let's now use the entire quadratic formula. Okay. So I put the steps down and then we'll solve. Okay, so our steps. When we're solving the quadratic formula. Write your values for A, B, and C. Okay. Second step, find your discriminant to find number of solutions. 3, substitute in for the quadratic formula. And then 4, solve and simplify in simplest radical form. So put it in simplest radical form. Okay. So you guys can pause the video if you need to keep writing those down. Alrighty. So let's do the examples we just did. Whoopsies. We're going to do 2 of them. We're going to do 9x squared minus 6x plus 1. We're going to do 10x squared plus 11x minus 6 equals 0. And then I put a really difficult one on there, okay? All right. So we already did the discriminant for examples 1 and 2, right? So look at your notes. 9x squared minus 6x plus 1. We knew the discriminant was 0, so we know there's going to be one real root. Okay, so that saves us time on this one. So now we're going to substitute in for the quadratic formula. So opposite of b, what's the opposite of negative 6? So let's put our values down for a, b, and c. So a equals 9, b equals negative 6, c equals 1. Now let's substitute in. X equals opposite of b, so opposite of negative 6 is 6, plus or minus the square root of b squared, which is 36, minus 4 times 9 times 1, all over 2 times a. So what's 2 times 9? 18. All right, we already know what this is. This is 0. All right, guys? So we're going to put a little 0 down here because we already did that, right? What's the square root of 0? Nothing. So we have 6 plus 0 over 18, and we have 6 minus 0 over 18. So how do I simplify those? The first two, you're going to have two solutions, right? Which are going to simplify to one answer. So let me show you, let me prove it. So I want to show you that there's two because you have the plus or minus, but it's going to end up being the exact same answer, okay? So let me prove it to you, and then you'll know in the future, you just cross one of them up, okay? So 6 plus 0, 6. 6 minus 0, 6. So 6 over 18, how does that simplify? 1/3. So your answer to this one would be 1/3. All right? So do you see how that cancels down into only one real root? Because you're going to have the same. Dealing with the whole identity property of 0, right, guys? Okay, so let's try the second one. All right, so x equals, so let's do our values for a, b, and c. A equals 10, b equals 11, c equals negative 6. Now we did this one, and we know it's going to be two real roots, right? Because it's positive. So let's substitute in. Okay, so opposite of b, so opposite of 11 is negative 11, plus or minus b squared, which is 121, minus 4 times 10 times negative 6. So we had that as 240, which was the square root of 361. So 2 times a, so 2 times 10 is 20, okay? And I told you that the square root of 361 is 19. So we have negative 11 plus or minus 19 all over 20. Okay, what's negative 11 plus 19? 8, comma. What's negative 11 minus 19? Negative 30. Are those simplified? No, so we need to simplify those. 2/5, comma. Negative 3/2. Okay. Two real roots, right? Okay. Let's do the last one. This one's going to take some space though, so I'm going to erase the board so that we have the entire board to do this one, okay? So the next example is 2x squared plus 8x equals 5. So the first thing is that in standard form? Someone say no, no. We have to get 5 over to the other side. So that's the first thing we're going to do. We're going to subtract 5. And then I'm going to turn the board. Actually, no, I'm just going to erase this. Okay? All right, so leave yourself some space because this is where it gets interesting. I'm videoing, Trey. Dear Lord. Welcome to my world, people. All right, so example 3, 2x squared plus 8x plus equals 5. We're going to subtract 5. So then we get 2x squared plus 8x minus 5 equals 0. So I rewrote it, and now we're going to start. All right, so let's find our discriminant. B squared minus 4ac. All right, so A equals 2, B equals 8, C equals negative 5. So B squared, 8 squared is 64, minus 4 times 2 times negative 5. And yes, I want you to show all of this work. I do not want you to do that in your head. Okay, 64, what's negative 4 times 2? Negative 8. Negative 8 times negative 5 is 40 equals 104. Okay, guys? So, how many roots is that going to have? Someone say 2. 2! Okay, so we know when we get done we're going to have 2 roots. But is 104 a perfect square? No, it is not. So they're going to be irrational. Okay? Which means we're going to have a simplest radical form when we're done. All right, so let's substitute. X equals, what's the opposite of 8? Negative 8 plus or minus, we just did it, 64 plus 40. We're just going to put 104. Okay? I'll let you do that shortcut. All over 2 times A, 4. All right, so then we have to ask ourselves, what are 2 factors of 104 that are going to give us a perfect square root? Can you give you guys a couple seconds? So remember our divisibility rules. If the last 2 digits are divisible by 4, then we know it's divisible by 4, which means that it's perfect square root. Am I right? What?
26 and 4.
Yes, thank you, Evan. Show off. All right, so we know it's 26 and 4 because it's divisible by 4. So take 4 and run with it. And 26, you can't simplify it anymore, can you? Someone say no. So 4 and 26 it is. So we have x equals negative 8. So perfect square of 4 is 2. So we're just going to put that to the outside of our radical like we did last chapter. And can you silence that for me? Okay, so square root of 4 is 2. We bring that to the outside of the radical. We leave root 26 in there, and we put that all over 4. Now, time out. So remember when we were dividing radicals. If I have whole numbers that are all divisible by something, can I take them out of all of them? Someone say yes. Yes. What can I take out of these 3? 2. So we're going to make this a 2. We're going to make that a 1. We're going to make this a negative 4. Now we're going to simplify. Okay? So can I combine this negative 4 with this negative and positive square root of 26? No, because it's not like radicals, right? So we have to leave them separate. So we have negative 4 plus square root of 26 over 2. And we have, comma, negative 4 minus square root 26 divided by 2. Okay? Give you guys time to write that down. Okay? So I want you guys to think about this and think of questions you may have. Okay? That was a whole lot of notes that we simplified down into about 30 minutes. Okay, guys? So think of questions you may have after watching this and bring those questions tomorrow. And we'll do more examples tomorrow and see how you guys are doing. We'll add some word problems and some area and all those other good things in there. All right? That's all I have for you. Watch it twice if you need to, okay? Make sure you have discriminant and quadratic formula memorized if at all possible. Standard form of a quadratic memorized. Okay, and I will see you tomorrow in class. Thanks, guys. Bye.